This is SpaceTime Series 28, Episode 134, for broadcast on the 14th of November 2025. Coming up on SpaceTime, have astronomers finally seen the universe's first stars? Discovering hidden secrets about our moon and the asteroid Vesta. And Europe's Euclid spacecraft peers deep into a stellar nursery full of baby stars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers believe they may have finally detected some of the very first stars to shine in the universe. A report in the astrophysical journal Letters claims observations by NASA's Webb Space Telescope has detected what appear to be population 3 stars in an ancient galaxy catalogued as LAP-1b, which was a background galaxy gravitationally lensed by a foreground galaxy cluster known as MAX J0416. Population 3 stars were the very first stars to form in the universe, ending the cosmic dark ages and triggering the epoch of reionisation. That's when radiation from these first stars began to ionize the opaque gas that filled the early cosmos, turning the universe transparent and making it look the way it does today. These population 3 stars were extremely luminous, massive blue stars, composed almost entirely of nothing but pure hydrogen and helium, with maybe trace amounts of lithium thrown in. The stars were made out of only these elements because they were the only elements created in the Big Bang 13.8 billion years ago. See, all the other elements in the universe were manufactured through nuclear fusion processes during the lives and deaths of these first stars. The new Webb observations suggest that these population 3 stars were formed around 200 million years after the Big Bang. Now, big hot stars live fast and die young. They're the James Deans of the astrophysical world. And because they live fast and die young, they're extremely rare. One of the holy grails behind the development of the Webb Space Telescope was the possibility of getting a glimpse of the faint light shining from these distant, most ancient of all stars. Previous detections of population 3 star candidates have always been ruled out because they didn't meet the primary theoretical predictions of what their formation and properties should look like. See, in order to be a population 3 star, it would need to have been formed in small clusters of dark matter halos. It would need to be extremely massive, and it would need to have virtually no metallicity. Astronomers regard all elements other than the hydrogen and helium made in the Big Bang as metals. And the stars in LAP-1b appear to meet all these requirements. The population 3 stellar system was detected in a dark matter halo with a group around 50 million solar masses. And the stars themselves each appear to be quite massive, ranging from 10 to 1,000 times the mass of our Sun. Also, they were clustered together in small groups, totaling a few thousand solar masses. And finally, their spectral signatures suggest that the gas surrounding LAP-1b is of extremely low metallicity. It's not quite case closed yet, but the results are incredibly tantalizing. This is SpaceTime. Still to come, discovering hidden secrets about our moon and the asteroid Vesta. And Euclid peers deep into a stellar nursery full of baby stars. All that and more still to come on SpaceTime. Two separate NASA studies have revealed some fascinating hidden secrets about the Earth's moon and the main-built asteroid Vesta. The findings, reported in the journal Nature, are both based on spacecraft gravity data achieved simply by orbiting these ancient worlds. Although the moon and the asteroid Vesta are very different, the works resulted in groundbreaking insights about planetary structures. In the lunar study, the authors developed a new gravity model of the moon that included tiny variations in the celestial body's gravity during its elliptical orbit around the Earth. These fluctuations caused the moon to flex ever so slightly due to Earth's gravitational tidal force. It's a process called tidal deformation, and it provides crucial insights into the moon's deep internal structure. Using their model, the study's authors produced the most detailed lunar gravitational map ever recorded, providing future missions with an improved way of calculating locations and time on the Moon. They accomplished this by analysing data on the motion of NASA's GRAIL, Gravity Recovery and Interior Laboratory mission. Its two spacecraft, known as Ebb and Flow, orbited the Moon between December 2011 and December 2012. The other study focused on the asteroid Vesta, a frozen rocky world in the main asteroid belt between Mars and Jupiter. Using NASA's Deep Space Network radiometric data, as well as imaging data from NASA's Dawn spacecraft, which orbited the asteroid between July 2011 and September 2012, the authors found that instead of having distinct layers as expected, Vesta's internal structure may be much more uniform, with at most a small iron core, or possibly no core at all. Both studies were led by Ryan Park from NASA's Jet Propulsion Laboratory in Pasadena, California. Park and colleagues used NASA's supercomputers to build a detailed map of how gravity varies across each body. From that, they could better understand what the Moon and Vesta were made of, and how planetary bodies across our solar system formed. Park says gravity is a unique and fundamental property of a planetary body, and it can be used to explore its deep interior. The technique doesn't require any data from the surface. Astronomers just need to track the motion of the spacecraft very precisely as it orbits a planet in order to get a global view of what's going on inside. The lunar study looked at gravitational changes in the Moon's near and far sides. The Moon's near side is dominated by vast plains known as mare, formed by molten rock that cooled and solidified billions of years ago. The lunar far side is far more rugged, with very few plains. Some theories suggest that intense volcanism on the near side of the Moon likely caused these differences. That process would have caused radioactive heat-generated elements to accumulate deep inside the lunar near side's mantle. And the new study offers the strongest evidence yet that this is likely the case. The authors found the Moon's near side is flexing more than the far side, meaning there's something fundamentally different about the internal structure of the Moon's near side compared to the far side. When comparing the results with other models, Park's team found a small but greater than expected difference in how much the two hemispheres deform. Now, the most likely explanation for this is that the near side has a warm mantle region, indicating the presence of heat-generating radioactive elements, which is evidence for volcanic activity that shaped the Moon's near side 2 to 3 billion years ago. The authors then applied a similar approach to their study of Vesta's rotational properties in order to learn more about this asteroid's interior. The technique is sensitive to any changes in the gravitational field of a body in space, whether that gravitational field changes over time, like the tidal flexing of the Moon, or through space, like a wobbling asteroid. Vesta wobbles as it spins. That allowed the authors to measure what's known as its moment of inertia, a characteristic that's highly sensitive to the internal structure of a body. You can see changes in inertia when you look at an ice skater spinning with their arms held outwards. As they pull their arms in, bringing more mass towards their centre of gravity, their inertia decreases and their spin speeds up. By measuring Vesta's moment of inertia, scientists gained a detailed understanding of the distribution of mass inside the asteroid. Now, if its inertia was low, it would mean there was a concentration of mass towards its centre. But if it's high, that mass would be far more evenly distributed throughout the entire asteroid. Now, previous studies had suggested that over long periods of time, Vesta would have gradually formed an onion-like layer and a dense core, a process known as differentiation. But the new inertia measurements suggest instead that Vesta is far more homogeneous, with its mass distributed evenly throughout, and only a small core of dense material, if any, at its centre. Gravity slowly pulls the heaviest elements towards a planet's core over time. That's how the Earth ended up with a dense core of liquid iron. And while Vesta had long been considered a differentiated asteroid, a more homogeneous structure suggested it may not have fully formed layers, or it may have simply formed out of debris from another planetary body following a massive impact. In 2016, Park used the same data types as the Vesta study to focus on Dawn's second target, the dwarf planet Ceres, and the results there did suggest a partially differentiated interior. Park and colleagues more recently applied the same technique to Jupiter's volcanic moon Io, using data gathered by NASA's Juno and Galileo spacecraft during their flybys of the Jovian satellite, as well as from ground-based observations. By measuring how Io's gravity changes as it orbits Jupiter, which exerts a powerful gravitational tidal force, they revealed that this volcanic moon is unlikely to possess a global magma ocean. This is SpaceTime. Still to come, the European Space Agency's Euclid Space Telescope peers deep inside a stellar nursery full of baby stars. And later in the science report, claims a natural sweetener derived from the stevia plant could help improve hair loss treatment. All that and more still to come on SpaceTime. The European Space Agency's Euclid Space Telescope has peered through a dusty veil of the mysterious interstellar gas and dust nebula in the dark cloud LDN 1641. In the process, revealing a spectacular stellar nursery filled with a multitude of shimmering baby stars. LDN 1641 is around 1,300 light-years away in the constellation Orion. It's in the sprawling complex of dusty gas clouds where new stars are being formed. In visible light, this region of the sky appears mostly dark, with just a few stars dotting what seems to be a primarily empty background. But by imaging the cloud with Euclid's infrared eyes, a fascinating panorama of star birth is being exposed. The new study shows that the nebula is teeming with very young hot stars. Some of these objects, embedded in the dusty surroundings, are violently spewing out material, a sign of stars being formed. These outflows appear as magenta-coloured spots and coils. Euclid was observing this region of the sky to fine-tune its pointing ability. For the guiding tests, mission managers required a field of view where only a few stars would be detectable in visible light. And this portion of LDN 1641 proved to be the most suitable area for study. The tests were successful, and they helped ensure that Euclid can point reliably and very precisely in any desired direction. This ability is key to delivering extremely sharp astronomical images of large patches of the sky at a very rapid pace. In fact, the data for this image was collected in just under 5 hours of observation time. Euclid is surveying the sky to create what will be the most extensive three-dimensional map of the extragalactic universe ever undertaken. Its main objective is to enable scientists to pin down the mysterious nature of dark matter and dark energy. But the mission will also deliver a treasure trove of observations of interesting regions in our own galaxy, just like LDN 1641. As well as countless detailed images of other galaxies, offering new avenues of investigation in many different fields of astronomy. This report from ESA TV.
In 1915, Albert Einstein astonished the world with his general theory of relativity. It described the behaviour of the entire universe, based on the matter and energy contained within it. The theory sparked the modern discipline of cosmology and the hope that we would finally understand how the universe came to be. But in recent times, the effort to define what the universe is made of has given us a very big surprise. Visible stars and galaxies make up less than 5% of the universe's total matter and energy. Beneath this visible layer is a mysterious celestial realm, consisting of shadowy particles and unknown energy fields. For decades, astronomers have puzzled at their nature, calling these elusive substances dark matter and dark energy. ESA's Euclid mission will go in search of the answer to the fundamental question: what is the universe made of? A European-designed mission, Euclid is built and operated by ESA, with contributions from the International Euclid Consortium and NASA. ESA selected Thales Alenia Space to lead on building Euclid, with Airbus Defence and Space providing the telescope and payload module. The telescope and scientific instruments form the heart of the mission. Together, they will observe billions of galaxies over more than 1/3 of the sky. Producing record quantities of data, Euclid will enable scientists to draw a precise map of the universe across space and time. This will allow researchers to investigate the effects of dark matter and dark energy on the apparent shape of galaxies and on their motion and distribution over immense distances. In turn, this will help reveal the true nature of dark matter and dark energy. The spacecraft and data communications controlled from ESA's European Space Operations Centre in Darmstadt. To cope with the vast amounts of data Euclid will acquire, ESA's EdgeTrack network of deep space antennas has been upgraded. These data will be analysed by the Euclid Consortium, a group of more than 2,000 scientists from more than 300 institutes across Europe, the US, Canada and Japan. Understanding the elusive nature of the universe has drawn astronomers throughout history. It remains one of the most challenging investigations in modern science. The Euclid mission is a quest into the unknown, a mission to shine a light on the dark side of the universe.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found a link between a person's IQ at the age of 18 and their risk of developing alcohol use disorder. A report in the Journal of the American Medical Association looked at around 600,000 people from the Swedish Military Conscription Register, which includes an IQ assessment, and then followed up with these people over an average of more than 60 years. Using a technique called Mendelian randomization, which uses genetics to allow scientists to determine whether one thing causes another rather than them simply being linked, the authors found a causal association between lower cognitive performance and the risk of alcohol use disorder, whereas the inverse was found for people with higher IQs. Scientists have developed a new type of bamboo-based plastic which they claim is strong enough to be used for industrial purposes but still able to biodegrade in the soil within 50 days. The research, reported in the journal Nature Communications, claims the product was able to match or outperform traditional plastics when it came to shapeability, mechanical stability and withstanding temperatures. The authors say organic-based plastics like these are often unable to handle tough conditions, making them unsuitable for areas such as infrastructure. But their plastic is made by breaking down bamboo cellulose using an alcohol solvent and then modifying the cellulose as a tough plastic material. A new study has shown that stavinicide, a natural sweetener derived from the stavina plant, could help improve hair loss treatments. The findings, reported in the journal Advanced Hair Care Materials, are based on research with alopecia subjects. The authors gave subjects a dissolving patch formulation of stavicide combined with minoxidil, a hair loss treatment that's approved but dissolves and absorbs into the skin very poorly. The authors found the patch helped effectively promote hair follicles to grow new hair, and they say this could be a promising step towards more effective treatments for baldness. Well, it seems flat earthers are at it again. This time, they claim to have direct evidence from NASA's own files that the Earth is flat and that the agency's been hiding the truth from the American people all along. Of course, in reality, the document they're looking at was simply pointing out the fact that when aircraft velocity is being calculated, you don't include things like the speed of Earth's rotation, how fast the planet's orbiting around the Sun, how quickly the solar system's circling the center of the Milky Way galaxy, or for that matter, how fast the Milky Way galaxy is moving through the universe and space-time. But why let the facts get in the way of a good story? Tim Mendham from Australian Skeptics says the gotcha moment falls a little flat when you're smart enough to understand the full context behind the paper.
I'm sure someone at NASA finally revealed the truth, let slip that the Earth is flat,
Whoopsie.
non-rotating. No, they got the sack. No, what it is, it's pretty ordinary when you get down to it. A lot of these things are. Someone was looking at documentation on NASA's site, so it's hardly secret, and they found the reports that in various assessments that were done, mainly of aircraft landings, aircraft flight, rockets in space, even a helicopter, they did their assessments on the basis that the Earth being flat and non-rotating, right, as to like the effects of variable wind speeds and aircraft trajectory and this sort of stuff. They were using it as flat because basically there's no difference.
Yes, because you're part of the frame, you're part of the picture.
That's right.
That's
yeah, I mean,
all about.
From the perspective of the flight, it might as well be flat, right, because of the size of the Earth, etc., and the distances you're talking about. But this, with the phrase in there, they were talking about describing it as if it was flat and non-rotating, because really it won't make a lot of difference to their calculations and the sizes and time periods they're talking about. So they do it just for the sake of measurements, not because they think the Earth is flat and is non-rotating. But someone necessarily, you found a few words in here and then you pull those out of context and then you say, see, NASA, top secret information published on their website for anyone to read, that it's flat and it's non-rotating. Sorry.
So cherry pick the words you want and leave the rest out.
Yeah, I mean, someone from NASA said that any aircraft, even a supersonic jet fighter, does not fly anywhere near a speed where the curvature of the Earth has to be accounted for in trajectory analysis. So only when you're talking about achieving orbit does the curvature come into play, okay? It can become significant, whatever. For all intents and purposes, airplanes in flight can be treated as flying over a flat domain. So, no, not secret. They haven't made a blunder. They haven't sort of secretly revealed this information. It wasn't secret. It had perfectly good reason for doing it. And apart from that, it's a non-story.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.